And what happened is that, okay, there is also this place called My BIM Center, all right. So if you wanted to know, okay, the growth of BIM in Malaysia, all right. So there is this center called My BIM Center, okay. If you want, okay, you can actually go and arrange, okay, a visit to My BIM Center. It's a rather futuristic place, okay, whereby CIDB is showcasing all the BIM capabilities, okay, for Malaysian industry, all right, okay. And there was a set goal, okay. What we need to have in our industry is that, okay, we projected that due to the requirement for projects in Malaysia, there need to be about 1,000 or more, okay, capable BIM, okay, modeler, or people that would actually go and work on the BIM models, right? So for that, okay, there were initiatives that was driven by the CIDB, also together with the Kementerian Pengajian Tinggi, alright? Okay. The other thing that's happening right now is that the creation of the BIM object library. Okay, so I think that is the idea is that you are going to get a local content that you can use, okay, for projects in Malaysia, and you know exactly where you are going to get this in order for you to construct it, okay, for the construction. Alright, so that is what's happening as well. Okay. Now, okay, so the BIM steering committee that I mentioned earlier, that I said was established in 2013, okay, and basically we were looking at the implementation that was done all over the world, right? So there were visits that was done to Singapore, to the UK and Hong Kong, right, in order for us to learn, okay, about how to implement, okay, BIM in the construction industry in Malaysia, all right? Okay, now, the other part that I wanted to share, alright, is, okay, about the effort that is actually being put by organization in order to adopt BIM, alright. So in this example, okay, I want to share about JKR, okay, Jabatan Kerja Raya, okay, or public work, alright. Now, the thing is that, okay, this is one of the government agency that actually look into adopting BIM for the purpose of projects, okay, that happens all over Malaysia. And their journey into BIM, okay, is not last year or 2 years ago. It happens way back, okay, in the middle of the 2000, okay, 2006, 2007. All right. Now, what happened is that, okay, there were a lot of steps that happens along the way in order to ensure that adoption can happen into the construction of government buildings. All right. So it takes a lot of steps to actually go and do this. Alright? So when you look into organization, okay, if you ever come across, alright, organization that is adopting BIM processes, okay, what you need to understand is that, okay, the journey that it took, okay, by all these organizations is not just a quick and simple journey. Normally it involves a lot of effort, a lot of investment, okay, and it involves a lot of, you know, time, okay, amongst all that, alright. So, okay, so this is the timeline, okay, what happened, okay, and basically out of this, right, the JKR for Malaysia, right, so they've actually produced what they call as the guidelines, okay, for BIM standards, alright. And if you want any reference, okay, for Malaysian's guideline, okay, for this, okay, you can actually, look for this document, okay. However, these are not gazetted document. They've actually created this, okay, but they cannot get it gazetted, alright. But if you search over the internet, somebody have actually go and PDF the entire thing, alright. So you can actually have a look at this, alright. They're not saying that you shouldn't have it. This is not under the OSA, alright, don't worry. Okay, you can look into it, and you can look into what are the items, okay, that is actually important, okay, as per what interpreted by this, interpreted by the JKR, right? And there is also this other document, okay, this is called Manual Process Kerja, okay, or Work Process Manual, okay, for BIM projects, alright. So this would explain, okay, what you need to do, okay, and basically what are the kind of processes that you would have, okay, in order for you to adopt BIM, okay. And they've done quite a number of pilot projects as well, right? Okay. Besides that, there were a lot of activities, okay, like I mentioned, okay, tomorrow there will be BIM Day, and BIM Day, this is I think the 4th BIM Day that we've done, alright? And besides that, there were quite a number of other activities, okay? And what happened is that somewhere around the mid of last year, okay, BIM got mentioned into the parliament, all right, where the ministers start pointing out that, okay, in order for construction for the government buildings to actually becomes more efficient, we need to look into BIM, all right, start adopting it, all right, okay. So more, all right. And in terms of the awareness on the student level, okay, our government have this thing called, okay, Industry Center of Excellence, ICOE. All right. With this ICOE, okay, what happened is that for students like all of you, all right, I mean, there is this BIM courses that you can take, okay, that is driven by the ICOE. Alright, so what they do is that they go around the country, okay, and they have conversations with the government funded or or self-funded university, alright, to actually go and drive BIM adoption. Okay, so that's what's happening as well. Alright. Okay, now let's look at the reality. Alright, if you wanted to actually go and move into BIM. Alright, now we've actually looked into the effort, okay, that's being put in place, okay, by our government, all right, and a little bit of history, okay, the backstory of BIM, okay. But the reality is, okay, right now, if you want to move into BIM, one of the challenges is because our industry is very, very much tied to, okay, another form of technology called CAD, okay, CAD, okay. The fact of the matter is that when you get into construction, about 85% of the construction data are all in CAD. Alright? So that's the number one challenge that happens in the industry nowadays. Okay? Now, okay, so the question is that what is CAD? Alright? So CAD actually stands for Computer Aided Design. Okay? Or, alright, it's not so much Computer Aided Design in Malaysia. It's the D, okay, for CAD in Malaysia actually stand for Computer Aided Drafting. Alright, so that's what's happened. Alright, so we use computer to help us to actually do drafting. Okay, that's why you get this kind of documents. Okay, so I believe you have looked into the drawings, right? Okay, architectural drawings, alright. Structural drawings, alright, M&E drawings, right? So, I mean, what about these drawings that is challenging? Alright? So if somebody give you this kind of drawings, alright, so how is it challenging? Okay, anybody care to guess? What is the problem with CAD actually?
It's actually a 2D model.
Alright.
It doesn't give you the visual appearance of the building when it's 3D.
So basically what you're telling me is that it lacks clarity, correct?
Yeah.
Alright. So that is the number one challenge of what CAD is. Alright. So you have a drawing. Now, it's not just drawings. It's a technical information. Alright. And it's open to interpretation. Okay. Alright. So compared to this have a lot more visual impact. It is straight away understandable. Alright, you don't need to be 15 years old, 15 years experienced engineer to understand what these are. Alright, okay. Now, in terms of software, alright, CAD has been around very long time. Okay, I mean, it got very popular way back in the 1980s, alright. And basically, okay, that also goes together with the hardware that we have. Okay. Now, looking back at a little bit of technology, right? Okay. So why we can do what we do right now is because of the growth of this, technology in terms of computing power. All right. Now, I would like to ask you this, right? So if I have the most, if I have a regular computer in the 1980s compared to what I have right now, how many more powerful do you think that the computers that I have today compared to what I have in 1982? How many more powerful? How many times more powerful? I mean, I have this question. When you want to buy a phone, all right, you look at what? You look at the spec. What is the? You look at the spec, right? Sometimes people just look at the brand, right? If it's Apple, I just go and buy it, all right? Okay, but most of us will actually look into the spec of the phone, right? So you look into the RAM, okay, and you look into the processor, right? Okay. Now I have this question: when NASA sent people to the moon, how many RAM do they have to do all the computings? Never thought of it, right?
2 gigabyte. No, 2 gigabyte.
2 gigabyte, right? So he says 2 gigabyte. He have a lot of idea. I like it. Alright, that's fine, okay? 2 gigabyte, right? 1967, alright? NASA sent people to the moon. They only have 4 megabyte of RAM. 4 megabyte of RAM. Nowadays, you go and buy a phone, 4 GB is low already. Okay? Alright? So, what I'm telling you is that, okay, the power of computing is getting, okay, more and more affordable. Alright? But at the end of the day, what are we using, those power for? Alright? Okay, so same like this, alright. So for personal computing, alright. So if you compare to what happens in 1982 when we first have CAD to now, okay, the power of computing actually grow, okay, to the tune of close to 100,000 times. Okay, that is how much computing that we have nowadays. Alright, so that's why we need to move away from this CAD. Okay, now. Okay, so what happens in our industry is that we are moving away from, okay, what we used to have, okay, which is paper and pen, alright, and then we have now computer, alright. So even if you talk about computer, okay, we are referring to this type of computer, alright, okay, it is still something that is attached to your desk, okay, and basically, alright, you now have this thing called cloud computing, alright. So if you use your Facebook, if you use your Google Mail, alright, or I don't know, Twitters and whatnot, all those are basically cloud-based application, alright. And what we are using our phone for is basically just as an access, alright. Okay. So that is what's happening in the technology side as well, right? So we move to handphone, alright, and tablets, right? Now, okay. The problem with CAD, okay, let's go back to the problem with CAD, alright? So before this, okay, we need to move from CAD to BIM, and we have the technology to actually do that right now, okay? But what is the problem with CAD? Okay, the problem with CAD is this, okay? Now, you can be given these 2 lines in CAD, correct? Okay, somebody give you a drawing, 2 lines, alright? So what does this mean? It could mean anything, right? Okay, somebody say wall, maybe, alright? So if you're a mechanical engineer, you might say, no, it's a duct. Alright? Okay? So then you start to actually see, oh, okay, you're given more information. Alright? Then it reinforces your understanding. Oh, okay, this could really be a wall. Because I see a lot of wall being drawn like this. Okay? Now, the problem is that is your interpretation. Alright? Again, a mechanical engineer can say that, no, that is a duct with insulation. Alright? Which is still true, alright? And, okay, for all you know, you got the scale wrong, and what it really is this.
Tree.
Okay, so it's a rubber tree, alright? So that is what could happen, alright? I could give an architect a very complete, all right, a mechanical engineering drawings, and he wouldn't understand those. All right, because why? Because okay, drawings are, you know, cryptics, you know, very cryptics. Okay, so you have a lot of information that you need to interpret on your own. Okay, which is very dangerous. Okay, with the complexity that we have for our buildings right now. Okay, so this is an example of a 2D drawings. I know it's a little bit blurred, all right, but this shows a cross section of an MRT. All right, try to understand those. It will take a very long time. All right, okay. Now, that's why we need to actually go and move into 3D models. All right, so we move from CAD to BIM. The first thing that you do is to appreciate the fact that you have 3D models. With 3D models, it's clear. All right, because why? You understand the physical aspect of the elements that you have. A wall is a wall. It's not going to be something else. All right, okay. So that's the benefit of actually moving to 3D model. Okay. However, if you wanted to, okay, technically you want to, compare what is CAD and basically what is in Revit, okay, parametric software. Okay, this is also with regards to how the elements are being, being designed in this application. All right. So if you've used Revit before, you know that it comes in a nice package. All right. When you put a wall, it is a wall. It's not going to be something else. Alright, but if you have AutoCAD, you draw lines and you put on layers. Alright, and people need to interpret what that layers mean. Okay, you have this kind of information. Alright, so what I'm trying to say is that, okay, moving to BIM would enable you to have a universally understandable form of information that would make, okay, this guesswork unnecessary. A wall is a wall, a door is a door, a window is a window. Alright, now let me paint you a picture. Alright, so we do, okay, quite a number of international based work. Alright, and what happens is that we have drawings that comes from China. Alright, and we were being asked to look into it and try to build a 3D model out of this. Okay, it's very difficult because none of our team members actually speak Chinese. Alright, okay, and okay, we don't understand what those are. Alright, even though it's labeled correctly on the layers and whatnot. Okay, now on the other project, we were given a model that was created in Korea. Alright, now the difference is that when we get the information from Korea, we understand straight away. Because why? Because all the elements, okay, I don't know what the Koreans call wall. Okay, but I know when it comes to my computer, it is a wall. Alright, so I don't need to, you know, do an interpretation of what those informations are. Alright, so these BIM tools are becoming a universal language for you to be able to do your work worldwide. Alright, so that's what happens. Alright, so it takes out the need for you to translate this information. Okay. Now, there is this other things with families and blocks. Maybe you are not really aware about this, okay? And the other thing is that, okay, there are some differences in the way that how you can treat the information, right? So with CAD, the informations, the team that you have is a little bit more fragmented, okay? And then the process that you have is actually more, it's actually more sequential rather than linear, all right? Sorry, it's linear more than rather than concurrent, okay, for BIM, alright, because when you have a BIM data, okay, you can start with enough information to allow other parties to come in and join, alright. In CAD, you can't do that, alright. So, I don't know how much exposure that you have to CAD drawings, alright, okay. But let's say that if you want to estimate the cost of building a house, okay, what you're gonna have is basically just the floor plans, right, and then you have the elevations. And then you have the sections. Okay. Now, the sections that you normally get are normally the simplest section. Okay. The sections that you know. All right. But when you want to get to a more complex area, nobody have that information. Not even the designer themselves. All right. And that's not going to happen if you work into BIM. All right. Okay, and then there is also about communications, right? You communicate 2D, all right? Okay, it's not holistic. You'll be missing a lot of information, all right? Compared to if you actually go and start doing things in 3D with BIM. Okay, now there is also this thing about what or quality of information that you have. Okay, moving from CAD to BIM. All right. So I just want to touch on this a bit. Okay. Now, when you move into BIM, what you'll be able to do is you're going to be able to have a lot more information front loaded. Okay. So that means that you would do a lot of work initially. All right. But how that is going to benefit on the construction is this, all right? On your building life cycle, you have the schematic drawing, detail drawings, construction drawings, and construction. Okay. So what happens is that because you are front loading your work, you are going to have a lot more ability to control costs, and the cost of design change is actually minimized. Okay, because you do a lot of work here. Okay. One thing that everybody need to understand: moving to BIM doesn't mean that you're going to do lesser work. Alright? Now, there was this problem in the industry where a lot of players start to look into BIM and says that, okay, if I have BIM in my process, that would cut a lot of people from the work. Which is not true, alright? Because based on this study, this thing actually have a name. Alright, if you want to look for it, the explanation of this, you can Google this name, McLeamy curve, not McDonald, McLeamy curve. Alright, so he's the president of HOK, and he comes out with this graph, alright, that shows how much effort that you need to put for your work and when. Alright, so if you look at the area here, it's the same. It's just that the work come earlier for BIM. Alright, so that's what's happening. Okay, now the next thing that I wanted to touch is with regards to BIM terminology. Alright, so I've been talking about 3D a lot. Alright, so you have an idea what 3D is, right? We understand what 3D is. Basically, even for cartoons nowadays, I have little kids, alright, and they watch cartoons, alright. All those things in Disney Channel or whatever, it's all 3D nowadays. Even the Mickey Mouse is also 3D nowadays, alright. So 3D is something that, for your generation is very normal. Not so much to my generation to the next step, alright. But 3D, what you need to understand is, when we refer to 3D in BIM, it's not just about geometrical element. It's not about something that have volume. It's not just about that. It must also come with data. Alright? So if you have a 3D element that is just volume, alright? So that is not the proper 3D that you should get from your BIM model. Alright? So now the consequences of this is basically this, right? When you work into BIM with 3D, there will be some smart guys that say that, I can give you a SketchUp model. You know about this software called SketchUp. Have you heard about it? Alright. Basically, SketchUp does not contain much information. It's just geometrical. Alright. So, if you are going to actually have this kind of information into your BIM process, you're going to have a very big challenge. Alright, because there is no explicit information inside the the SketchUp model. Alright, so that's what it is. Alright, now so when you can look at this pyramid. We have 3D, 4D, 5D, and 6D. Alright, so 3D is basically the 3D model, architectural BIM, structural BIM, MEP BIM. At the basic of it. And then 4D, we are talking about scheduling. Alright, so if you are doing construction management and planning, alright, so you know that you need to plan the construction. So it's not just about getting the information together, but you need to see how you're going to construct this. Alright, so that is why we have this 4D stuff. Alright, and 5D is for you that is doing quantity surveying. Alright, so that is what we call as 5D BIM. Alright, and 6D, okay, is basically some information that is touching into facility management. Alright, so now for 3D, okay, what you can do with 3D information is that you can actually have the visualizations, you can have rendering, you can also get something that is in the form of laser scanning information. Alright, you can actually go and do visual programming. So these are the benefit of having 3D information. Alright, so 4D, alright, so this is where you actually have your project phases. Okay, so if you come to a term whereby, okay, you need to have a BIM process with 4D, that's what you should be doing. So that means that whoever that asks you to do that process require you to have a project planning attached to the model. Alright, so that's what you're going to have. Alright, now for 5D, it's actually about the cost information. Alright, now this is a little bit more challenging. Alright, because okay, when you talk about costs, okay, for construction, alright, if you are referring to information that comes out of somewhere like Revit, okay, so what you're going to get out of that mostly is basically just quantities. Alright, so when we talk about costs, okay, there are two other things that you need to consider. What are the things that you need to consider, at least? Besides the quantity, what are the things that you need to consider for cost? Anybody want to help me? Come on. You guys are taking quantity surveying, right?
How about taking off? Taking off.
Yes. Okay, if you want to get to cost, right? What do you need? Alright? So if how do you know that, okay, it's going to cost X amount of ringgit to actually go and build this building, given you a drawing or basically a Revit model? Dimension is quantity, right? Okay, that is given. What else do you need? Pardon? Specifications. You can get it from the 3D model as well. Correct? What else that you need?
Unit price.
Unit price, rates. You are correct. Okay, so besides the quantity, you also need rates. Alright, so you have labor rates, you have the material rates. Okay, and these are something that you cannot straight away get out of the BIM model. Alright, okay, so for example, right, I can give you a Revit model, okay, that have a wall that is 4 meter high. And there is another Revit model, okay, that actually have a wall that is about 1.5 meter, but the surface area that is covered by the wall is the same. Okay, so one wall is longer, the other wall is taller. Alright, would the cost be the same to paint the wall? Why? Surface area is the same. Let's say it's the same. It's just that one wall is longer but shorter. The other wall is not. It's not as long but it's taller. Labor cost is different, right? Okay. So that's why you need to be careful. If you have a Revit model or if you have a BIM model, you need to look into how the model is built as well. Don't just go and take it and start doing your calculation. You might be off. Alright? So that is one of the critical area, right? That you need to understand if you are to go and take 5D, okay, from the BIM processes. Alright? It's not as straightforward as we would like it to be. Alright? And you need some sort of like a special tool in order for you to analyze the BIM models. Alright? Now, okay, so I have this, okay, just to paint this. Okay.
The pace of change is increasing. Our construction industry is moving on, and it's a pretty cool journey. I'm pleased to announce that we have moved past just clash detection and spinning 3D models around on the screen. Winning work now requires integrated workflows that truly exploit the use of building information modeling. Hold on to your hats as we take you for a ride through the only fully integrated 2D, 3D, 4D and 5D BIM-based workflow. Vico Office is the most integrated virtual construction
Just one of the